Welcome to OpenSCAD.
What you gotta get through.
So this is the OpenSCAD talk. OpenSCAD is a CAD program. So the point of this talk is to both tell you about how to code in OpenSCAD and show you a little bit of some of its examples, also some of its children. So this is how you would install OpenSCAD. I'm going to be giving this to the guys who yeah, too eventually, but some of the guys who do this. Basically, OpenSCAD is amazing, and I'm going way too fast apparently. I skipped 6 slides.
The computer is going fast.
Okay. That too. So we have a joke here. We pop into the mic. The cheat sheet is pretty good. The user manual is pretty good. These are excellent links that you should go to. So, how do you code in OpenSCAD? It's similar to C in that you declare variables the same way, you do comments the same way. They used to have a limitation where you could only declare variables at the top of the file, yeah, where you can actually change the files now, but they've changed it somewhat where you can declare variables at the top of the module declaration. Basically, it's very similar to C, where you have the it's similar to what do you call
C?
it? Well, don't. Well, I mean, be that guy. It's similar to type definitions, where or say again?
Nothing?
Yes. I can't. Nobody. Nope. I can hear you. No one else can hear you.
It's the point, Phil. That is the point.
So basically, in OpenSCAD, the point is declaring primitives and translating on the primitives in order to build shapes and in order to create useful objects. So you have cubes, you have spheres, you have cylinders. So you also have other objects. This is how you declare these things. Polyhedrons are Bob?
Is it 3D only or
No.
2D?
So you can actually what you can do with 2D is you can project onto a 2D object or onto a 2D plane. So it's not only 3D. What you do is so OpenSCAD will project onto 2D, and then you can export into DXF, which is a 2D format, which can then be used for CAM for later, yeah. So no. The primary use of OpenSCAD is 3D. So its primary use is STLs, but no, it can be used for 2D. And actually, I have an example later on that does 2D. So here we have 2D So later on, we do. So one of the examples, or one of the really powerful uses of OpenSCAD is its ability to take inputs for use in programs or modules. So you can set it up so that it takes inputs. This is a really relatively simple example where basically it's setting up so you're setting up cylinders to move it around. So the point that I can't stress this enough. The strength of OpenSCAD is in the difference and the intersection operators and in the translation operators. Basically, its strength is in building these structures. You can basically what you see here is a very simple couple of translated cylinders that are intersected or differenced, but you don't necessarily have to do just cylinders. You can do cubes, which basically allows you to do any kind of three-dimensional rectangular shape, or you know, on top of cylinders, et cetera, et cetera. Basically, I've got examples later, but it's very. I mean, this is the strength of OpenSCAD right here. Is these differences and intersections right here. Translate, obviously. So OpenSCAD is very similar to VRML in that it allows you to translate, move around, scale, resize, do all those translations. It allows you to operate on matrices similar to you know, if you're familiar with matrix arithmetic, do that sort of thing. Some of the more entertaining transformations are some of the offsets. Colors allow you to do RGB. They actually have a dictionary of some presets colors, so you can, rather than doing the RGBA, you can do a instead of a open bracket, closed bracket, you can do a quote and name the color. And some of those colors, they actually have a large range of colors that work. So you can do color. some of the chamfers are pretty important. So specifically, the hull and projection are very useful. So later on, I'll have examples for the hull and the projection, but hull basically allows you to merge the outlines. It's not a union, but basically it connects all the way around a so here we have two here, and it goes around. This is basically a lazy man's 3D way of describing a shape. So what you can do is you can just describe 3 or 9 points and describe a shape without having to worry about whether or not the shape is closed or open. Whereas if you actually do the polyhedron, you have to worry about whether or not it's open or closed. So one of the other options is doing.
Hey, does that projection take a vector?
So projection is a way of taking a 3-dimensional object that you just created and then pushing it into a 2-dimensional object.
Yes, but I'm asking, does it take like as an argument or some parameter,
Orientation
low
for
variable?
projection.
Yeah, which direction is being projected on the plane?
That would depend on how you were importing it into the object. So you could import an object, basically extend it into 3 dimensions, and then export it out to 2 dimensions again.
So all the transform has to take place on the
Yeah.
3D plane.
Yes. Also, one of the strengths of OpenSCAD is loops, conditions, stuff like that. So one of the things that I've done recently was if statements and for statements, or for loops. So basically, you declare an object and then you extend it later on. Like it builds out of that. You can use that for translations. You can use that for I don't know what you would use that for other than translations, but so you can also import previously defined SDLs. These are 3-dimensional objects that have been defined. OpenSCAD or not OpenSCAD. Thingiverse is a website for pulling 3-dimensional objects from basically that other people have put out. Yes. And you can take those 3-dimensional objects and import them into your model, and then translate them and do things to them. So you can import them, you can translate them, you can scale them, you can do all the interesting things to them in order to use them for your use.
Does the STL support color that you had earlier?
You can apply color to things.
But it doesn't have it in
Say again?
there. STL doesn't have color in it.
No.
Okay.
STL is basically a point cloud. So some of the derivatives that OpenSCAD has, these are things that people have taken OpenSCAD and then built either or extensions to or code generators for OpenSCAD. So one of the interesting things, it's very Scratch-like in that it shows you explicitly the scope of what's going on. BlockSCAD. Oh gosh, this is.
Just that.
Crystal SCAD is used in a couple of open source projects, specifically the
United Airlines.
C.
no. So a couple of the open bio projects. So there's a group out there that's building tools that are useful for developing countries for building like tools for. So one of the some of the tools are like what do you call the ear?
Hearing aids.
No, it's a tool for looking into an ear to see whether or not it's infected. Another one's a gauze loom. There are a couple of biologically useful tools for developing countries that are using Crystal SCAD. They basically have their objects that are defined in Ruby, and they compile it to OpenSCAD, which then they compile to STL. Solid Python's another one that basically is similar, where they're defining objects in Python that then they compile to OpenSCAD, which compiles to STL. JSCAD is another one that they compile to, or that it's more of a visualization tool. So here we have more examples. This was a part that I designed for MOG that used an STL and some OpenSCAD and combined them together in order to 3D print a part for a 3D printer. So that's actually more the power of OpenSCAD is the ability to take an STL and combine it with another STL or describe an STL. So here's an example of BlockSCAD. BlockSCAD is really an interesting tool where basically it allows you to visualize the scope of variables and allows you to describe what an object is. So here's an object that was describing a pump. And then here was the pump being used in another object. Basically, I got this far and then decided that it was, I had designed too far with far too many magic numbers. So magic numbers are, as we all know, a bad thing. So basically, this was the object in OpenSCAD, and this was the object after it had been cut out, projected in 3D and implemented. So basically, this is more the object. So, I guess at this point in the discussion, do we have? I'd like to open it up to audience participation. Do we have any questions? Yes.
Do you remember PowerPoint POV ray tracer?
I remember PhreakNIC, but I did not ever use PhreakNIc.
It kind of reminds me a little bit of it, kind of algorithmic 3D scene generation.
Yes.
But that was meant for ray tracing camera purposes.
Right.
Not solid level. Still, kind of reminds me.
Yeah. So for me, this is reminiscent of VR now. I came up more in the virtual reality model language, and so it's more reminiscent of that to me. Yes.
How do you do placement? I have not been in here for that portion.
Say again?
Like placement within the 3D environment?
Yeah. So
Can you give like example?
going back over here, that goes back into the transformations. The translate function is basically what you use for that. So it's XYZ.
Oh,
But the neat thing about translate is that you can operate over whatever's inside the scope. So there you can either describe a specific primitive, or you can open a bracket and then describe everything that's inside the primitive,
okay.
or everything that's inside the bracket. So
Now is it like translated at the center of the module, or is it like at one specific?
well, that's dependent on how you describe the primitive,
Okay.
or the contents. So
Does anything recognize its syntax?
say again?
Do you have anything that recognizes OpenSCAD syntax? Like Notepad++ syntax coloring?
I don't
Just an idiot.
I don't think so.
Emacs does.
Oh, OpenSCAD is a doesn't.
What?
Hey, down in the front, okay?
Oh, it's,
Yeah.
oh.
It opens it.
Well, no, it's planned in the package system.
I thought it was just.
So, for example, you see this translated here. This is describing this is translating against the wall thickness plus a magic number 5 against the tube condenser, which is this this flat part here. So it's basically calling a function that's describing that.
What is the purpose of the object described by the code on the screen?
Oh, this was a drink bot that I didn't quite bring to
like a
fruition.
drink bot.
Which I didn't
Yeah.
should have watched Mog's talk.
Log hadn't given his talk yet on how to finish.
Yeah. I almost brought it to fruition.
It was finished enough for you to make a slide with a photo of it, so that's.
I almost
Shame.
Yeah, there is a little bit of shame. A tiny bit of shame.
Not enough.
I am not unshameless.
Waves of shame.
He's working on that surplus right now.
Yeah, this was where it was last night, or the night before last.
You should go get it. We can work on this.
Yeah, we need some data sets.
Say
We
again?
need some data sets.
Unit testing.
Yes, yes. We'll be waiting.
But can it be recreated?
Well, I mean, it already exists.
Yeah, this is meat space, right?
This is in fact meat space.
I'm pretty sure this is CGI.
Yeah, this is.
Yes.
It's a render.
Yeah, this is just a render.
It looks like.
So that's
Somebody
a,
exported this to
that's an app
PLD
mega
and it's.
right there.
I have a follow-up question.
Yes.
Drink bot?
Yes.
That's the question.
What did you?
Ah.
What is it?
So I don't.
Each of the pumps hooks up to an alcohol
Yes.
and dispenses premixed
Have you
drinks.
also noticed that on the ingredients? What number of drinks you can make?
So the original plan was that it was going to have a menu that you could select a variety of drinks. And then I began playing with the Mega and playing with PWM and discovered that my original plan was incompatible, and so then I started doing Mog's thing where I expanded my scope. Scope tree. But, yeah.
So, definitely measuring it would be one problem.
So basically, going back to my talk. So basically, part of the point of this talk was to describe what BlockSCAD was, which BlockSCAD is a really interesting tool. It's basically a visual representation of what's going on with OpenSCAD. Yes.
Is it kind of like Simulink?
I've never used Simulink.
Oh.
It looks a lot like Simulink.
Does OpenSCAD not give us a visual at all?
OpenSCAD gives you basically the compile, or well, I mean, what you're looking at here is OpenSCAD. This is OpenSCAD. I mean, so where I'm zooming around here.
Are we looking at
This
actual
is
OpenSCAD now?
This, yes.
Okay.
This is OpenSCAD. I'm badly zooming and doing OpenSCAD. So, yes, OpenSCAD does visualization. What BlockSCAD does is it allows you to visualize what's going on in the scope. So it gives you more information about what's what, not necessarily variables, but yes, it also gives you variables. As you can see here, basically what it does is it allows you to describe variables. Here, these are all variables. The problem that I've found with OpenSCAD is, or with BlockSCAD, is that it tends to allow you to describe objects. Like basically, what's happening here is there's a loop that's describing this 5 objects here, and then then I'm translating that loop and describing that behind that. That's actually on a GitHub that is published. If you look for an Albertine/Dricot on GitHub, you'll find the stuff. But basically what's happening what's happening here is there's a whole lot of definition here. It's not as fast to define these blocks and these primitives as it is to do that in code. It's much faster in code to describe a variable and then use the variable. So BlockSCAD is useful, but it's useful from a visualization perspective. Also, BlockSCAD is
So would you recommend if someone doesn't code a lot, would they start with BlockSCAD then? Is that?
I would completely recommend BlockSCAD as an introduction to OpenSCAD. BlockSCAD starts here. It's not showing.
Hi, I'm Dagmar.
So if you, and this link is in the presentation, which will be published to PhreakNIC. Basically, BlockSCAD.einsteinsworkshop.com, and then if you go over to the code section, it will show you what you've done in OpenSCAD, which you can then copy and then paste directly into OpenSCAD, and it just works. You can also set it to save, and it will save it in XML, which is useful.
Will it generate the BlockSCAD from OpenSCAD?
Yeah. Well, from OpenSCAD, no, it won't go the other way. You basically have to build it in BlockSCAD.
It won't generate this from.
No. OpenJSCAD will. You can basically paste stuff into OpenJSCAD, and JSCAD is using. Let me see if OpenJSCAD is basically a visual terminal. It's very similar to OpenSCAD, but it allows you to visualize stuff in the same way. But this is basically a JavaScript version of OpenSCAD that also allows you to export to SCAD. So basically,
Well, not basically.
I guess some of the other see
That Ian needs to shut up, apparently.
who?
Ian.
Someone yelled that from the other room.
So going back to the various transformations, hull is a really useful command. Basically, you can describe three-dimensional shapes, and it will extract and pull those into another shape. So this is how I defined the. Where is it? So when Mog first asked for this particular piece, here we go. So basically, this was a part that was used for a 3D printer that Mog had asked for. What you don't see here is the sensor that fits down in the cylinder hole there. Basically, the So basically, this is describing the shape, or a shape that is a cylinder here, or a cube that's flat here and then flat here. And it's describing the pyramid against this shape. So that's, it allows you to be slightly lazier, where you're basically just pulling, you're describing a simpler shape, moving it against what you want, and then you don't have to Say again?
I'm sorry, this guy's singing behind you, it's just.
Oh. Getting ready for karaoke. Do I have any questions?
So how does that actually make it into a triangle?
So what I'm doing here is I'm describing a flat plane here and a flat plane here, and it's pulling it's pulling the it's creating the union of those two objects.
But
So-
you're not describing that union. You're just
No.
describing the two
It's-
objects and putting them in,
Yep.
and it's building it for you.
It's like it's wrapping it with like saran wrap.
Yeah. Yeah.
Oh, that's another way to think about it.
So hull is very useful.
I can hold myself with that one.
Also, projection. So at the make shop, we have a 3D printer. Projection is used for creating DXFs. So basically what you do is you take a three-dimensional object and you imagine, if you will, a light that is passing through the object against a flat plane, and that's basically it. It then takes the what's passed through and
So if you have like projectile shining onto an object, but
Yes.
it's still behind on a flat screen.
yes, directly against the object. So there's no spread.
Okay. And what is that useful for?
So DXFs, a lot of CAD, like CAM programs are use DXFs. So basically, what you can do is I'm using the word basically a lot.
Basically.
Sorry.
Basically.
So. So, so what you do is it, a DXF is a two-dimensional projection that a CAM program can then load in and then use for creating cuts in 2 dimensions. So a laser cutter can go in and cut 2-dimensionally. A CNC machine can then go in and you can tell it, for this particular part of the object, cut
So no
this
one
deeply.
thinks about it like in a 3D.
Right.
Just thinks about like, okay, so yeah, the laser cutter example just filled everything up for that way.
Yes. So that was actually how I, actually is another one of my pet peeves. I don't like the word actually. So this was cut out of 1/4-inch MDF. I threw a big chunk of MDF on a laser cutter and blasted out these pieces. So that was how this was done. Any other questions?